Hello students, good morning everybody, and hope you will be fine at your home. And we are going to study today the physical properties of group number 17th. So these are the physical properties: physical state, atomic and ionic radii, density, melting and boiling points, ionization energy, electronegativity, electron gain enthalpy, or we also say electron affinity, non-metallic character, oxidation state, and in last, color. So let me see one by one. First we take physical state. Fluorine and chlorine are gases at room temperature. Bromine is a liquid while iodine is a solid. Reason: as the size of atoms increases on going down the group, the strength of van der Waals forces that is directly proportional to the size also increases from fluorine to iodine. This is why the state of agglomeration means the tendency of molecules to come closer increases, and there is a gradual change from the gaseous state to solid state on moving down the group. So physical state is directly proportional to the size, and size is directly proportional to the van der Waals force of attraction. Atomic and ionic radii. The atomic radius of a halogen atom is the smallest in its period. ये आपने याद रखना है कि पीरियड में सबसे लो एटॉमिक रेडियस जो रहती है वो सेकेंड लास्ट एलिमेंट हैलोजन फैमिली से होता है. द एटॉमिक एंड आयनिक रेडियस इंक्रीज ऑन मूविंग डाउन द ग्रुप. Explanation: on moving from left to right in a period, the nuclear charge increases but number of shells remains the same. Thus the effective nuclear charge experienced by valence electrons in halogen atoms is the highest. This is why they possess the smallest atomic radii in their respective shells or period. The atomic and ionic radii increases on moving down the group. This is due to the addition of new electronic shell to each succeeding element. Next property is density. The density of halogens increases on moving down the group, and this is due to an increase in the state of agglomeration as explained above, based on van der Waals force of attraction. And agglomeration means the tendency to come closer, and the increases density. Melting and boiling points. Halogen possesses low melting and boiling point. The melting and boiling point increases on moving down the group. Reason: as the size of atoms increases on moving down the group, the strength of van der Waals forces existing between their molecule also increases. That's why they possess increasingly higher melting and boiling point on the group. Fifth property, ionization energy. The ionization energies of halogens are very high. The ionization energy decreases on moving down the group. Explanation: the very high ionization energy of halogens are due to their small atomic radii and high effective nuclear charge. On moving down the group, the size of atom increases, and consequently the ionization energy decreases. Next we take the sixth one, electronegativity. Halogens possesses very high values of electronegativity. In fact, each halogen is the most electronegative element on its period. The electronegativity values decrease on moving down the group like this. Explanation: high values of electronegativity of halogens are due to their small atomic radii and high effective nuclear charge. So these are the two reasons: small atomic radii and high effective nuclear charge. Nuclear charge plus shielding effect. High effective nuclear charge. On moving down the group, the atomic radii increases and effective nuclear charge decreases. That's why electronegativity of values decreases from top to bottom, from fluorine to iodine. Electron gain enthalpy or electron affinity. There are three cases. First is halogens having maximum negative values of electron gain enthalpy. Reason can be halogens are short of one electron to attain the nearest noble gas electronic configuration, as we know, and therefore therefore they show a greater tendency to take one electron to attain stable noble gas configuration. The high effective nuclear charge also helps them to take an addition of electron. Thus, a large amount of energy is released when an electron is added to the valence shell of a halogen atom. That's why the halogens have maximum negative electron gain enthalpy. So after 7th point, we proceed 7th sub B point. The negative electron gain enthalpy of fluorine is unexpectedly lower than that of chlorine. So due to small size of fluorine, the electron density on, this is the main reason of electron density, that increases the electron repulsion on fluorine atom is very high. The high electron density does not let fluorine atom to accept the incoming electron because of high repulsion in between the electrons as smoothly as in the case of fluorine atom. Third sub point, the negative electron gain enthalpy values decreases. First increases from chlorine and then chlorine to iodine decreases. In going from chlorine to iodine, the size of atom increases, therefore the force with which the incoming electron is attracted towards the atom is reduced. Okay, and this is why negative electron gain enthalpy values decreases from chlorine to iodine. 8th point, non-metallic character. Due to their high electron activities, all halogens are typical non-metals. However, due to a decrease in electron activity down the group, iodine exhibits a slight metallic character also. ये भी याद रखना है कि iodine down the group has a little bit of metallic character in the sense that it has a metallic luster and has a tendency to form monopositive ion and tripositive ions under specific condition. So iodine has a little bit of metallic character. So after 8th point, we take oxidation state. 9th point, oxidation state depend also on the excitation, and this is the excited state of the general electronic configuration of 16th 17th group. This is the general electronic configuration. With the first excited state, this electron will excite in this. Second excited state, this electron will excite into this, and third excited state, electron will excite here. So after excitation, the number of unpaired electrons are increasing, and if the number of unpaired electrons are increases, then their covalency will also increase. Let me see. Fluorine exhibits only the oxidation state of -1 in all its compound because fluorine is of small size and is most of electronegative among other halogens. The other halogen exhibit -1 +1 +3 +5 +7 oxidation states in their compounds. Reason: the oxidation state of -1 is the most common oxidation state of halogens, and when a halogen atom shares a electron with a more electronegative element, the oxidation state exhibited by it is +1. ये भी याद रखना है. When is showing +1 oxidation state after sharing with more electronegative element. Except fluorine, all other halogens atom possesses vacant d orbital in their valence shell and can therefore excite their electrons from ns and np electrons pair. This leads to unpairing of electrons, and the unpairing electrons can form covalent bonds with the lesser electronegative atoms. This enables fluorine and other heavier halogens to exist in higher positive oxidation state like +3 +5 +6 and +7. The energy required for the unpairing of electrons and their excitation to anti orbitals is compensated from the energy released in the bond formation by the unpaired electrons. In addition to the above mentioned oxidation state, chlorine and bromine also exhibit +4 +6 oxidation state in their oxides and oxoacids. So these we will study next. Last point, 10th, and is the most important point. Okay, all the halogens are colored. The color darkens on moving down the group, as is clear from the following. So pale yellow, dark color greenish yellow, then reddish brown and violet. So what is the reason of darkness of the color down the group in different halogens? The color of halogens is due to the fact that their molecules absorb a light in the visible region. This leads to the excitation of their outer electrons to higher energy levels. Since the size of atom increases from fluorine to iodine, the excitation energy involved in the process decreases progressively from fluorine to iodine. Thus, the small fluorine molecules absorb light, high energy violet light, and show the complementary yellow color. And here I am going to tell you what is the meaning of complementary. If light is absorbed with a low wavelength, then the emission of the radiation will be take place in higher wavelength, and vice versa in respect of frequency. So while large iodine molecules absorb low energy and green radiation to show the complementary violet color, this is why the color of halogens darkens on moving down the group. So this is one of the most important question related to the color of the halogens, why the color of halogens on moving down the group becomes more dark. So this is all about the physical properties of